Hello friends, in my this video I am going to discuss one of the very important and interesting algorithm which is known as two-pointer approach, and this particular algorithm can be very helpful for solving many problems which can be easily understood that in which problem you can use this kind of technique. Okay, so just let me start with one particular example. Suppose I have one input array 2 5 and the elements are 2 5 8 12 30. Okay, so these are the five elements, and I am asking you have to determine whether there is any pair in this particular array. If you add those two particular number in the pair, you will get the target sum as 17. Okay, so if you observe in this particular array, there is one particular pair whose addition result will give you 17, and that is 5 plus 12, right? So basically, if such pair is present, then you have to return the index positions of those pair. So in this particular case, 5 is in second index and 12 is in fourth index, so output should be 2 and 4. Okay, so if you are using Java, then you know that in case of Java, array index starts from 0. So 5 is belonging to index position 1 and 12 is belonging to index position 3. Then in that case you have to return 1 and 3. All right, so how you can solve this particular problem? Try to think about that. Pause my video, implement that in Eclipse or NetBeans or any other online compiler, or in other language also. If you want, you can do, and then check what can be one efficient solution, what I am going to discuss in my this video. Okay, so what one simple solution comes into our mind, that we will use one for loop for iteration from beginning to the end, and another for loop also we will iterate from beginning to the end. Suppose the first for loop is for int I equal to 0, I less than array length I plus plus, and second for loop for int j equal to 0, j less than array length j plus plus. Then if I not equal to j, that means if obviously two index positions should not be same, if I not equal to j, we will add those two elements. So if this is array, if the variable of array name is a, so a of I plus a of j equal to target element 17 or not, like that we will check. But if we are going to use one for loop inside another for loop, that is nested for loop, then obviously the time complexity will go to O of n square. So we have to decrease that. We want to solve this particular problem in O of n time complexity. How we can do that? See, one very simple idea. What we will do, we will use two pointer approach, and the two pointer approach says we can solve this particular problem in this way also. We will make two pointer. One pointer will point to the beginning element of the array, and another pointer will point to the last element of the array. So basically, if we define two pointers as I and j, I will be 1. Okay, because in this case array index starting from 1. In MATLAB, array index starts from 1, right? I hope you know this. And the j second pointer will be 5, which is pointing to the last element of the array. And we will calculate the sum. So 30 plus 2 will result into 32. So 32, and our target is 17. So 32 is greater than 17. So it is not matching. So what we will do, we will move our pointer. But we will move our pointer with some proper logic. Okay, so like we cannot move randomly, then there will be no meaning of optimizing this particular problem. What we will do, either we will move our first pointer which is pointing to the beginning element, or we will move our last pointer or second pointer which is pointing to the last element of the array. When to move which pointer? See, very simple, you can understand very easily. As in this particular case the array is sorted, obviously this particular algorithm is can be used only in case of sorted array. You have to understand this. See, the first pointer is indicating to the first element, the second pointer is indicating to the last element. So last element is the maximum, first element is the minimum now in this sorted array. Now we are getting the addition result as 32, but our target result is 17. So we have to decrease our pair sum Now as we have to decrease our pair sum, so say tell me how we can decrease the pair result, sum of the pair. Very simple. We have to point, we have to move the j or the second pointer, which is basically pointing to the last element. We have to move the second pointer to the left hand side, because the array is sorted format and we have to decrease the addition result. So see, it is j is pointing to the maximum, so we have to go to the smaller element, so we have to move the j pointer to the left hand side. So j was initially, it was 5, we have to make j as 4. Simple. So simultaneously build the algorithm. If the pair sum is greater than our target, then in that case we will move our second pointer to the left hand side. That's what we have done here. 30 plus 2 results into 32, but our target is 17. So that what we are doing, we are decreasing our second pointer to 4. So j equal to 4. Now in this case, I hope it is clear. Now what are the position of two pointers? I equal to 1 pointing to the first element, and 12 here, j is pointing to the second last element. 12 plus 2 how much? 14. 14 is lesser than our target element, so we have to increase the total pair sum. So as we have to increase, what we can do, we have to move our first pointer to the right hand side. So that what has to be done, I will be incremented, and I was in 1 initially, I have to make as 2, so I will point to the element 5 now in this particular case. Now you see 5 plus 12 is 17, which is our required result. So the algorithm will work in this way, that if x of I equal to x of I plus x of j, if the array is stored as x variable, so if x of I plus x of j equal to our target, then well and good. But if it is not equal, then what we will do, we will move our pointer. And how we will move our pointer? If we will do like this, if x of I plus x of j less than our target, then we will move our first pointer to the right hand side. And if x of I plus x of j greater than our target, then we will move our second pointer. And in which side? Obviously in the left side, because the array is sorted. This is the most important funda. So the code can be shown like this. Very simple code. CLC clear all close all. If you want, you can write warning of also. X equal to input, enter the sorted array. G equal to input, enter the sum result. Okay, so we are taking the input and the sum result, which we have to compute. Okay, and then what we are doing, I equal to 1 and j equal to length of x. Two pointers we are defining, one at the beginning of the array, one at the end position of the array. And then temp equal to 0 we are defining, and temp will be 1 if we find such pair whose addition result will give us g, okay, which is our target sum. And res equal to an empty matrix we are defining to store the index position if we are finding such pair whose sum will result into g. So while I not equal to j, okay, this is our condition when we have to break the loop. Why? Because if I equal to j, that means two pointers will arrive at the same position, and that will no longer be a pair, that will be a single element. So that while I not equal to j, we have to use like this. We will do our execute our while loop up to this. As soon as I equal to j, we will break that. While I not equal to j, if x of I plus x of j equal to g, that means we we have already found our target pair. Then we will store those index res equal to ij and temp equal to 1 and break that if condition, break that while loop. Okay. Else if x of I plus x of j greater than g, if the pair sum result is greater than g, what I have told you, what we have to do, if it is greater than, then we have to move our right side pointer to the left hand side, because it is greater element, so we have to decrease the result, so we will move our pointer to the left hand side. Okay, so else if j x of I plus x of j greater than g, then j equal to j minus 1. Else if the resultant sum, pair sum, is lesser than our target sum, we have to move our left side pointer, which we have initialized in the beginning, we have to move to the right hand side to increase the total sum result, I equal to I plus 1. That's all in this if else, in this while loop. if temp equal to 0, that means no such pair has been found, so no display no such pair exists. Else, that means if temp equal to 1, display res, display the index positions where you found out the pair. That's all. And tick tock, I have used here tick and here tock to get the CPU execution time. That's all. So Control A, evaluate selection, enter the array. Suppose let me take this particular array, Control C, Control V. Okay, enter the sum result, that is 17. Enter that. See what result we are getting. 2 4. So second index position is 5, fourth index position is 12. 5 plus 12 is how much? 17, right? So I hope you have understood the two-pointer approach. Very powerful algorithm to solve different kinds of numericals or problems in different service and product company based placement process. It may come as helpful tool to solve or optimize any particular problem. And this I have shown in MATLAB to I just wanted to make you focus on the algorithm, and syntax is very simple. You can, if you understand the algorithm, you can implement the same code in your favorable language, whether that may be Java, C++, Python, whatever. Okay, this is all for my this video. I am going to post the same code in the comment section. Thank you for watching.